This is Mary Montgomery for Assignment 5. Looking at question 1, skybox. We created a skybox header and CPP file. As you can see, we're utilizing the model class because we need things like the standard vertex and triangle by index structs, as well as just creating models and using the associated functions that come along with models. So with our skybox class, our private data is a pointer to a skybox model. We can delete these constructors and operators. The only constructor we use has a device parameter and a scale size parameter, which is how we adjust the size of the skybox. We have our destructor and we have our render function. So looking in the CPP file, we have our constructor. It's all kind of the same as the other cubes we've created, except for skybox, our faces are inverted, which means they're facing inward, so we need to switch the windings. That was kind of the main difference. So we set up our faces. All of these points, the X, Y, and Z, need to be scaled by scale size, so we're creating the correct size skybox, and then our UV coordinates all depend on the TGA file that I chose. And then after we create all of our faces, we create our new skybox model using what we've just created, and then we can delete our two arrays of the verts and the triangles to finish it off. In our destructor, we just delete our pointer to our skybox, and in render, we're just utilizing the model classes set to context and render functions. So then dxapp.h, we just have to create a pointer to a skybox, our skybox textured. In our dxapp.cpp, there weren't very many changes to make. We just had to load the skybox texture file, which is my good skybox. So I do want to point out, in my skybox texture, there are artifacts along the edges of the sky, which are kind of annoying and a bit noticeable. I also set my skybox up in a square, so I wouldn't have to deal with the thirds, and we just have to deal with the quarters. It still wasn't perfect because it's gotten from the internet, but I think it was a little bit more convenient. I created a sample state. I chose the clamp filter, just in case we went out of bounds on the UV texture, which is clamping the sky to the rest of the box. I just used a linear filter. Then I created my skybox object and decided on the scale size. Mine's huge, just because it looks more rounded that way, kind of just visual preference. And then I rendered the skybox, which is just calling that render function from our skybox.cpp file. And rendered out, we get our snowy scape. There it is. You can kind of see the artifacts a bit from the texture, but to make it line up, I kind of had to keep the artifacts in there. With the ground, there's no artifacts to be seen, but yeah, that's my skybox. Looking at question 2, terrain model, we have our terrain model header and CPP files. Just like skybox, we're utilizing the model class with the structs and the functions in model. The only private data we have for our terrain model is the model itself, the pointer to the model terrain. For our public functions in terrain model, we have a constructor and destructor, and we also have helper functions that I wrote that were just helpful for myself, find pixel height and texel index. Then we also have our render function. Looking at our terrain model.cpp file, we have our constructor. This is the code that was given to us, which takes our height map and turns it into an array of bytes. So the first thing I did was initialize the vertex buffer and index buffer based on what we discussed in class, where the number of vertices is n squared, the number of triangles is n minus 1 squared times 2. First I made a vertex buffer, where I figured out the start position, and I'm keeping track of the x current position, z current position, and figured out the distance between the vertices, so that I can place them evenly spaced apart per side. Next was dealing with the UVs. We're using a wrap filter and dividing the verts up based on how many times the UV repeats. And then we start our loops. So I'm going through, just like reading a book, where the top left is the 0th, and then kind of just going through row by row. So incrementing I means we're moving to the next row. We're keeping track of our current positions. Incrementing K means we're moving to the next column. So first we calculate the pixel height with our find pixel height helper function. And then we are setting our vertice. We have our x current position, our z current position, our y is our pixel height that we found, plus any translation value that got passed in the parameters of our constructor. Then we also have our current u value and our current v value. At the end of each column, we increment our x current position and our u current position based on our vertice calculations, and at the end of each row, we increment our z and our v's current positions. Moving on to our index buffer, I figured out up here, sort of just like using a visual, just first 2 rows of a 4x4 terrain, just what the triangles would be, and then how to programmatically decide how to make the triangles. So that is implemented in my while loops, again, just going row by row. And then we need to increment j here because we don't reuse the last vert in the row, so 3 never gets these triangle creations called on it. We just need to go right to 4. And then finally, we just create our new model made of our vertice and list arrays, and then we can delete those arrays after we've passed them into our model and created the pointer to our model terrain. Next are just the helper functions. So my find pixel height is what calculates that h value and calls my texel index other helper function. I'm returning max height times h value divided by 255, which is just how to find like the equal value within our range of height based on the h value, 0 to 255. Texel index is the helper function, find the location in the byte array of our ij index. And render needs to set the terrain to context and draw it. Again, we're using those model functions, set to context and render. And then finally we have our destructor, which just deletes our pointer to our model terrain. In dxapp.cpp, I kind of have two little demos. So first is just with the HMTest16, so we can see that the test is working. This only repeats the texture once, or the UV once. So we can see our test working just as expected. I also want to show just when we repeat, say repeat 3 by 2, to show that the UV repeating is working, which doesn't line up the test anymore, but it's at least easy to see that the UV repeats as it should here, which is harder to see when we switch to sandgrass. So these are just creating the textures with our texture files, and these are creating our terrains, our actual terrain model, using our height map and these other. I had to write down the parameters so I would remember what they all are, but the length of the side, the max height, the Y translation, repeat U, and repeat V. So we filled in that here in the dxapp.cpp file. We also, I changed the camera speed, it moved way too fast for me. And then finally rendering the plane, which is called our render function that we made in our terrain model.cpp. And let's render this final one with my height map and the sandgrass texture. Let's back it up. And there's my height mapped, textured, big terrain model.